Alright, so in today's video we're going to be talking about energy. We're going to talk about it in the way we all normally use it, and we're also going to talk about how this word has a very specific use in chemistry. So first, our warm-up here. If you are doing this on your own, you can just kind of write down your answer to these questions, or think about your answer to these questions. I may have given you a little worksheet to fill out with them. What types of energy have you learned about before? This could be just thinking about energy in your daily life. I don't have a lot of energy today because I'm pretty tired, that kind of thing. It could be maybe you've learned words like kinetic and potential energy in physical science. It could be energy in biology. You guys learned a lot about energy in biology last year. Anything you know, really. In what context do you remember learning about energy before? I just gave you some more ideas for that. Context means different places, so it could be a class, it could be in a story or in your daily life. Where have you kind of learned about energy before? And our bonus question, if you did learn these specific types in physical science in middle school, a lot of people usually remember these, but it's okay if you don't. What is the difference between potential and kinetic energy? So we're going to talk a little bit about what kinetic means. It's okay if you don't remember these words, but if you happen to remember this, that's a good kind of bonus to test yourself on there. Alright. And so again, you can take some time to answer those questions to yourself. This is a video, so we can't share out. I might have given you a way to share them with me if you're watching this video as part of class. Let's start with just our everyday use of the word energy. So it's a word we all use kind of every day. This picture on the left here, this poor kid with 2 backpacks. He's so tired he has 2 backpacks. Has low energy. I put some ideas on the right hand side here. Maybe he has too much homework. Maybe he has to go to work after school. He has to babysit his little siblings. He has so much going on that he's being spread too thin. He doesn't have the energy to do anything. He's tired. We can all relate to that. I often, when I'm talking about energy in my daily life, it's usually talking about not having enough of it. And then we have this guy over here who only has 1 backpack. He's full of energy. He has enough energy to jump in the air. Maybe he has the day off. Maybe it's a half day. He gets to go home, right? I think you guys get the idea. This is a word we already know. We already use it. And it might seem kind of silly to use these little pictures. I know you guys aren't little kids. But it's helpful to keep in mind this everyday use of the word energy will help us to understand the chemistry use of the word energy too. So don't forget about these little guys here. So the science use. This is the definition of energy in the science world. So it's a little bit more technical than what we'll use, but it's going to be helpful in building. We're going to kind of take our everyday use, take this super technical use, and figure out exactly what we mean in chemistry class when we talk about energy. So the definition is the ability to do work. And work, again, in our daily life, it could mean homework, it could mean working a job at McDonald's, taking orders, working the drive-thru, it could mean laying bricks or working on a house, right? And all of these things we do that are work. Use your work means what you think it means. Don't forget about that. But in science specifically, I put quotation marks around work because it is in science defined as the force to move an object. So in science, energy is specifically the ability to move something, to cause movement. So if we go back and think about these guys, the low energy person physically is not moving very much. They're tired, they're slow. The high energy person is jumping up in the air. They could maybe go play sports or something. They've got energy to move stuff. This person does not. There's a reason we use these words in different places. So in science terms, energy is the, right down here in this blue box, the ability to move something, to cause movement to happen. So here are our states of matter. We are talking about energy in the context of the states of matter. This picture here might be a good one to like screenshot, or maybe I'll post it for you on Google Classroom or whatever later. It shows you kind of an example of each state of matter. You guys probably know solid, liquid, gas. A lot of people also know plasma over here. I'm pointing at things with my mouse, but I don't know if you guys can see that or not. There's an example on the top of each thing. There's our diamond, liquid juice, gaseous clouds, neon signs have a plasma, ionized neon gas or plasma. We're not really gonna, you can kind of ignore that far right side. We're mostly gonna talk about solid, liquid, gas. And we have these particle diagrams, these pictures of what the atoms in each substance are doing that you guys might have seen before in, maybe in middle school or elementary school. Our solid, if we were doing this in person, I would want you guys to make some of these connections, but I'm going to show you some. Our solid is locked in place. That's what these little lines between them represent. And notice they're actually further apart. A lot of people want to say solids are close together, liquids are further apart. Look at these two pictures. That's not what we're seeing here. Right? That's not what we see here. The solid is actually further apart. In the liquid, they're packed very close together. And in the solid, they're being separated. So we're not talking about how, we're never going to be talking about how close together they are. We're going to be talking about how much energy they have. And so in the solid, they're locked in place. They're vibrating really slowly. A lot of people remember that. They're not sitting still. They're vibrating in place. In the liquid, they're moving all over the place past each other in this little thing. That's why you could stick your hand in this container of juice if you wanted to. Yes, that's a hand. And then in gas, they're far apart. They're moving way past each other. This is why we can't even see gases most of the time. Clouds are an example of a gas we can see, but there's gases all around you in the room you're sitting in right now that you can't even see because these little atoms are so small and they're spread so far apart. And we're not going to really talk about, we can come back to that later. So our highest energy is our gas. It has the most movement, right? Look at these long arrows I drew to show that they're moving as much as they can. The liquid is moving just a little bit, and the solid is just vibrating in place. So our gas has the most energy, our liquid has a little bit less energy, our solid has the least energy. It's still moving, it still has energy, it's just not a lot. Okay, so I brought up this word kinetic energy at the beginning because I usually find that a lot of people remember it from middle school. If you don't, that's fine. But kinetic, you might know this already. If I asked you, if we were in the classroom together and I could ask everybody what is kinetic energy, I usually get a lot of people who remember. But kinetic means, it just means movement. So it's just the fancy, I'm going to circle this little part right here. Kinetic is the fancy science word for movement. So kinetic energy just means it's moving. It means the energy in, we talked that energy is just the ability to make something move. So when something is moving, that's kinetic energy. So we see that here in this picture, all of these little particles with the arrows, that's showing movement. So that's a type of kinetic energy. These particles moving, just like we saw in the last slide. And we have this person running over here. She's also using kinetic energy. She's running, I added these little lines so it looks like she's running even faster, so you can see her kinetic energy. So both of these are kinetic energy, they're movement. And these two questions, I'm not going to answer them, but they might be a good thing for you to think about on your own, especially if our class is online right now. Think about which phase of matter do you think has the most kinetic energy. You can think of all four of them or just the three most common ones. You can look back at that picture on the last slide if you need to, or rewind this video a few minutes because I explained it. And which one do you think has the least energy? And do you think that they all Would it be possible for an object to have no energy at all, or no kinetic energy at all, for it to not be moving whatsoever? And that might be a big question we can come back to later. So here is more, we're kind of repeating what I talked about on slide 5 with all of those pictures, but there's text now instead of pictures. How is energy related to states of matter? In that image from slide 5, you can see that the gas is more spread apart. You can see that it has more energy. It shows there's little arrows at the bottom that show that we're moving from left to right towards the most energy. If we need to add energy to change something from a liquid to a gas, where does that energy come from? This is where the problems we're going to solve. We're not just going to talk about what the energy is, but we're going to talk about why it's changing. So this is where, like, the problems we're going to solve are going to come from this type of question. And another question to think about related to that is, how can we increase the kinetic energy of particles? How can we make things move, little particles that are too small for us to see? How can we make them move faster? We can't just like can I shake up my orange juice and make the particles move faster? Or is there another way to do it? So generally, it's going to be heat. Heat is going to be our energy source in these types of problems. And this is one that I think can be kind of hard for people to make sense of, but hotter particles are moving faster. Like when it is hot, and if we're sitting in our physical classroom and the air conditioning is out of sync and it is hot in there, in a sense the air is moving faster. The particles in the air are moving faster, and when it's colder they're moving slower. So we can always think of energy as movement, and we can think of heat as it's a type of energy. It's all energy is all energy. We just call it different things depending on what it's doing. So if we add energy to, let's say, ice, or to water, or to whatever our object is in one of these problems, it is going to cause changes in the energy. It might cause a change in the phase energy. It might cause the attraction to break between those solid particles so that they can melt into a liquid, or it might cause a change in the thermal energy. It might just make the particles move faster so that they're hotter. This is just literally making something hotter, which is what we think of as heat doing. But this overcoming the attraction is something heat can do as well. And this is something that probably sounds like nonsense right now, but we'll practice it a lot and it'll start to make sense. The most important thing right now is that energy can do one thing at a time. It can do this, it can do phase energy, or it can make it hotter. It can't do both at once. And this is again repeating these technical terms. There's two kinds of energy involved in phase changes. They're not really different energies though. It's just this heat is doing two different things. The heat can act as thermal energy and make increase the temperature, make the particles warmer. It can act as phase energy. It can make things melt or evaporate. Those are our two jobs that energy can have right now. And so, let's see, I put this slide back here just because I think we need the visual one more time, but this is a video, so I'm going to make one final point on this video, and then we'll have a couple more. There will be another video on how to read the graph you're about to see, and there will be another video about how to draw the bar charts. So this is just our introduction to energy, so we're almost finished. So again, we can see this energy. If we add energy to this system, let's say we take this diamond, let's pretend it's just ice, because diamonds don't melt into juice, but we want to show something melting. So let's say this is ice. If we add heat to this, the heat is going to make these particles vibrate faster. It is going to make them move faster. It is also going to break apart these attraction to turn it into a liquid. and it can only do one thing at a time.